In this problem, we have a kind of a complicated mechanism, which I haven't drawn, but you can see in the book. And we're given all the dimensions that we need. And so it's kind of going through the same procedure as we've done in lots of previous problems, is writing all the position vectors. Okay? So I used A as my origin, and so then I have position to B, C, D, E, G, and F. So there are three members in this mechanism. So we're going to have actually lots of equations and lots of unknowns. What we can see from, generally speaking, is that the FG, which is the, I defined as a point on the body where load P acts, and I used, let's see here, G is where the 360-pound load acts, and Q is the 240-pound load. So I defined two new points here to where the external loads act. And then we also know that because point E is on a roller, that the force is, there's only a force component in the x direction, and the force component in the y direction is 0. And that's good because we have lots of unknowns here, and we have two forces, force at A, force at B, force at C, and force at D, and so two components each, that's 8. And then the force at E gives us 9 unknown force components, and so we need 9 equations. So we need to do force and moment balances on three different sections or subsections of this mechanism. And so what I did is I did just sum the forces and moments all over the entire body. So we have just the external forces acting from the where it's connected to the wall, connected to the ground. So those are at A and E, and then we have our applied loads at F and G. And then I looked at just the horizontal bar, remember, with loads that act on it are loads at A, B, and D. So this is an external load from the ground, and these are B and D are internal loads. So then I looked at the member, let's see here, A, B, minus. Let's see, what did I actually do here? I don't think that's B minus, but what did I do? Yeah, why did I write that down? That's not what I looked at. Yeah, that's not. So let's get rid of this guy. And let's see, what body did I actually look at in my analysis? ECD. So I looked at the vertical member. So I did forces C, and then D, I got to put a minus in front of the D force because it's an internal load, and on member CDE, it needs to be acting in the opposite direction as on member ABD. So I just use this notation here, the minus sign, so that whenever the force here, it needs to have a minus sign in front of it instead of a plus. And then the other force is E that's acting. So for each set of these, we'll get 3 equations. So we'll get 9 equations, and we have 9 unknowns. And we can just crank through the algebra, and we'll get our forces that we're asked to determine. So we were asked to find the forces acting on member ABD. So at point A, we have minus 1,110 pounds in the horizontal direction. In the vertical direction, we have 600 pounds. At B, we again have minus 1,110 pounds in the horizontal direction, and minus 800 pounds in the vertical direction. And at D, we have 2,000 200 pounds in the horizontal direction and 200 pounds in the vertical direction. So those would be the, you can see that if we look at this mechanism, you can see that at A we have a lot of downward load, upward load reacting to the forces that are acting on this system. And in fact, this is equal to the total weight acting on the system, because there's only one external load, an external reaction force counteracting that, and that's at A. So that makes sense. And then at B, we have this would be let's see here, a downward load pushing at B, or yeah, a downward load at B. Alright, so that's counteracting that. And then at D we have an upward load, which makes some sense because again, it's counteracting some moments and stuff. Again, it's hard to tell exactly if these make sense. This one obviously needs to be clear there, but these other ones, it's hard to really make sense how these mechanisms transfer loads to the joints. And you really just have to do the math, but you can kind of look at the signs to make sure that things are looking okay. Makes sense that this guy and this guy are negative, because the moments acting are going to kind of try to pull this thing in from point E, and try to basically pull point A away from the wall. So that makes some sense. But basically, what you can do is think about how this thing might fail. If the loads get too big, is point A gonna, is this whole structure gonna pull away from the wall or push into the wall? Well, pull away from the wall, which means that the wall is pulling back on it, so we have a negative sign there. So again, these make some sense, but it's hard to get get anything much else from your intuition.